in C++, a function call that looks like this, right? A and then parentheses, and there could be some arguments here, x, y, z, a list of parameters. So this is considered to be also a function call operator. And function call operator can be overloaded in C++. So the name of the operator will be operator with parentheses, like this. Very similar to what we had with the subscript operator. The only difference here is that operator with parentheses can have any number of arguments. So this gives this operator lots of flexibility. So why would you want something like this? So we can create like object A, right? This is the class name, and we can create object name A, and I'm using lowercase. So this is our object, and then we can start using this object with parentheses and pass parameters. So the object becomes, the object starts to behave like a function that can be called with parameters, right? So this object, of course, can retain. We can do something like this in a loop, and XYZ are parameters that change in the loop, and we can run this loop, and this object may accumulate information after being called within the loop with these parameters. So that would be the idea. Such object that provides an overloaded function call operator is called function object or functor. Okay, and so that's the thing which is also available in some class libraries. This becomes very usable concept because C and C++ also allow to create function pointers, and the syntax can be sometimes inconvenient or not the best choice. So then in place of function pointers, we can start using functors, which are basically objects that we create, and then we can start using them in any context, where the function call syntax is used. A word of caution regarding logical AND and logical OR. These operators, logical AND and logical OR, could stir a little bit of confusion and may be somewhat questionable to use in the code. So let's see. So this is an example here. So we create this class, right? That's called Boolean flag. Okay, so this is class name Boolean flag. And this class contains Boolean variable mFlag. So this is a member variable private flag. And we have a constructor that takes the flag as a parameter, and naturally its constructor initializer list sets this flag to whatever parameter was given to the constructor. And then we provide an overloaded logical OR operator that, of course, is implemented in this example as a member function, just to conserve space and on this page right here on this slide. And what it does, it takes the flag of the object for which this operator was invoked, the left-hand side, and another, the right-hand side, and returns the comparison. Of course, this is perfectly normal, right? This is an OR, and this is a Boolean, which is true or false, and the other object also has this member variable right here, we implement this idea of logical OR comparison of the two flags. So there's just everything seems to be very logical and very much okay. There's nothing unexpected so far. Then we use a function named download, which takes the URL of some sort of resource, and we say downloading, right? So we basically trace the call into function download, and eventually, supposedly, this download succeeds, and we return true. So we construct Boolean flag, we give it true, we initialize its flag, and we're all done. Everything looks good, right? So it's best case scenario, our default case scenario, that everything is fine. So now we'll go to our main function, and we start testing this code. So we design some kind of or construct some kind of URL, and there's a file that we want to download, and we call this function download, and we pass the URL right here. And of course this, let's say that it succeeds and everything is normal, and we return the Boolean flag initialized with true value. But then what happens is that maybe we want to retry this, and we say, okay, if this is true, right, if this is true, then it should be short-circuited situation where basically this OR operator should just check the true right here, and if it's true, this should never be called, right? Because this operator should short-circuit and basically allow this to be true, and if it's true, this never executes. That's what every single programmer expects. This short-circuiting is something that comes with built-in types, Boolean evaluation of expressions, and so forth. So this is what we expect. However, the overloaded operator requires evaluation of both left-hand side and right-hand side, unfortunately, in this case, because otherwise how could this possibly, how this expression can be resolved? Well, because I mean, the outcome of this has to be known before this if statements can proceed. So because we require it right here, the right-hand side. And so therefore, overloaded logical OR and logical AND cannot short-circuit. They just cannot be short-circuited. So this is why this is the semantics of short-circuiting that we cannot provide by overloading these operators. So simple advice is to not to just do not overload these operators, because sooner or later that will be very confusing situation where you'll find that you or the users of your class will find a way where they would be expecting this short-circuiting to work, and it of course will not work. So that's something to remember. And it's basically, although you can overload these operators, just remember they may not be best candidates for overloading. Well, perhaps not too many classes behave like Boolean values. So then these operators, maybe you will not find them you will not find the need to overload them very often. But even if contextually they would make sense, the overloading these operators cannot provide short-circuiting, so it's not a good idea to overload them. Just leave them out and rely on member functions for the users of your classes to check these types of combinations and or and so forth. So in summary, we should use operators in ways which mimic the native use, essentially which remind the users of operators that commonly use with primitive data types such as integers and double values and so forth. So unexpected types mixed into unexpected use of operators would be confusing and should be avoided. For instance, operators such as increment and decrement probably just don't make any sense for class name string. And in that sense, you should not overload these operators because they just don't bring any value to the natural design of your concept, such as string. But at the same time, it should be like once you begin to overload the operators, right? So you just end up overloading operators. Some we have to overload, some we have to provide as convenience. But once you start overloading these operators, your users will probably expect all of these to be available. In other words, don't just attempt to overload one of these operators in this common group. Make sure that you provide the complete set. So if you overload equal, your users will probably expect not equal as well. And as I mentioned before, first you should just construct functions, implement functions that do the work. And then, as a reminder, most of our operator implementation right here just resolves as a single line of a function call in one of these functions that already exist, a part of our class operations. So be careful with data type conversions. Sometimes they come naturally, sometimes they come quite unintuitive. So copy constructor, remember we talked about this. Copy constructor should ring the bell that you also may need to have a move constructor and also move assignment and regular assignment or deep copy assignment. Prefer member functions over non-member functions for operations that need access to the implementation. So generally, we like when with example of operator overloading, whenever possible, I tend to use non-member operators. Only when it's absolutely necessary to use member function versions of these operators, I make them member functions. Using them as non-member functions is just fine. And so these are the rules, the guidelines for choosing member function or non-member function. And typically, if something like this requires access to private members, private data of the class, then it's an indicator that this operator should be considered to become a member function. If you can implement the operator relying only on public interface of your class, then it should definitely be implemented as a non-member.